Okay, let's dive into this. Welcome to the Explainer. Today, we are breaking down what is absolutely, without a doubt, the most massive paradigm shift in AI routing and economics that we've seen this entire year. On July 9th, 2026, OpenAI officially dropped the GPT 5.6 model family. But listen, this isn't just a simple version bump. No way. We're looking at a complete, ground-up restructuring of how artificial intelligence is packaged, priced, and deployed for complex workflows. Here's a quick look at our roadmap today. We'll start by meeting the GPT 5.6 family, then break down the Sol, Terra, and Luna tiers. After that, we've got the new modes and capabilities, followed by the pricing and prompt caching. And we'll wrap up with the Claude Fable 5 showdown. I promise you a deep dive into the architecture, the hard math of prompt caching, and the objective competitive benchmarks. Let's get into it. Section 1, meet the GPT 5.6 family, a paradigm shift. For the longest time, the AI industry basically operated on these single monolithic flagship releases. You got the big model, and then, I don't know, maybe months later, you'd get a smaller mini version. But with GPT 5.6, OpenAI has totally moved away from that old pattern. They've introduced a persistent, multi-tiered ecosystem designed to handle every single depth of work right out of the gate. And what was truly wild about this launch on July 9th was just the sheer speed of the whole shebang. At 17:02 UTC, Sam Altman confirmed the live stream. By 17:08, literally 6 minutes later, the global rollout had already begun. There was no weeks-long US first staged waiting period. By the afternoon, the entire 3-tier family dropped simultaneously into general availability across ChatGPT, Codex, and the API. And this brilliantly illustrates OpenAI's brand new strategy and their new naming convention. They're using this celestial metaphor, and it's meant to serve as these durable capability tiers that will persist across future generations. It's like a giant solar system. Sol, the sun, is the biggest, hottest, and most powerful. Terra, the Earth, is your balanced home base, and Luna, the moon, is the fast, cheap orbit circling everything else. Section 2, Sol, Terra, and Luna, the 3 tiers. Okay, let's see how this actually builds into real-world utility. Because, knowing the fun space names is one thing, but knowing exactly which planet your workload should live on is how you keep your engineering budgets from bursting into flames. So, here is your routing playbook. Just look at these unit economics. You should absolutely be using Luna for high-volume classification and low-latency routing. It's just a single dollar per million input tokens. Then, you default to Terra for your balanced everyday coding and document processing. But you reserve Sol, which, let's be real, costs a whopping $30 per million output tokens. You reserve that exclusively for long-horizon agentic loops and edge cases that demand absolute peak cognitive performance. Section 3, new modes and capabilities. Now, OpenAI didn't just give us different-sized models here. They give us entirely new ways to command them. GPT 5.6 treats computational effort not as some fixed trait, but as an on-demand, budgetable commodity. Traditionally, API loops are sequential, right? The model thinks, it takes a step, it waits, it takes the next step. Well, with GPT 5.6 Sol, OpenAI introduced Ultra Mode in their Responses API. Instead of navigating that slow, sequential path, Sol can decompose a complex prompt, spin up 4 parallel subagents simultaneously, and then synthesize all their work. It completely bypasses traditional wall clock latency for complex tasks. It's a real game changer. Then there's Programmatic Tool Calling. This is massive, guys. The model can now write JavaScript to orchestrate your tools natively. It passes results between its own internal calls and processes those intermediate outputs right inside an isolated V8 runtime. And it does all of this entirely without network access for maximum security. It is effectively running a secure sandbox right inside the API. Furthermore, developers can now explicitly dictate the reasoning effort. You can scale it from none all the way up to the newly introduced max. So if you've got a really high-stakes problem requiring absolute verification, you flip on Pro Mode. This grants the model a massive internal compute budget to perform deep error checking and hypothesis validation before returning one single, highly refined response. Section 4, Pricing and Prompt Caching. All right, all this incredible compute power brings us to the financial reality of the GPT 5.6 release. Listen closely, because if you do not route your workloads correctly, these new output costs are going to blow up your budget overnight. Now, what's really interesting about this slide is the sheer steepness of this cost cliff. Generating 1 million tokens of output on Sol costs $30. On Luna, that exact same volume is just $6. A long output response on Sol can easily cost you more than feeding a massive input prompt into Luna. You really have to be strategic here. To help manage these costs, OpenAI relies heavily on prompt caching. But there's a catch. For GPT-5.6, developers pay an explicit 1.25x cache write penalty for sending uncached input. Yep, you read that right. You are paying a 25% premium just to write your prefix to the cache initially. But actually, scratch that. It's not really a penalty, it's an investment, because subsequent cache reads receive a massive 90% discount. That brings the rate down to just 0.1x. So if you're running long agent loops that just resend system instructions and tool schemas over and over again, caching isn't just a nice little feature, it is the load-bearing economics that actually makes the platform viable. And when you compare this to Anthropic's Claude Fable 5, the philosophies differ sharply. OpenAI offers predictable, explicit breakpoints and a guaranteed 30-minute minimum cache life. Anthropic, on the other hand, gives you a 5-minute default time to live. If you want a 1-hour cache life on Claude, you're forced to pay a 2x premium on the cache rate. OpenAI's approach is just notably simpler for developers to model out financially. Section 5, the Claude Fable 5 Showdown. And this brings us perfectly to the final piece of the puzzle, the objective benchmark showdown between OpenAI's flagship Sol and Anthropic's flagship Claude Fable 5. Both of these are absolute titan models, and we are going to look strictly at the data. Let's see who comes out on top. On the Artificial Analysis Coding Agent Index, GPT-5.6 Sol claims the state-of-the-art title, scoring an 80 compared to Fable 5's 77.2. This specific benchmark aggressively rewards highly efficient terminal navigation, command line tool use, and rapid execution loops. Basically, in a sandbox environment, Sol is an absolute speed demon. It flies. But wait, the tables turn entirely when we look at SweBench Pro. This benchmark measures deep, complex architectural refactoring. And here, Claude Fable 5 absolutely dominates with an 80.3% score, leaving Sol trailing heavily behind at 64.6%. So, the crucial point is understanding exactly why Sol trails here. It's fascinating. OpenAI's architecture prioritizes localized task completion. It just wants to finish the job quickly. But in large code bases, this often manifests as agentic overreach. Sol has a bad habit of implementing massive, unrequested architectural modifications that drift entirely away from the developer's original intent. It basically tries to do too much. And this leaves us with a very clear framework for how you should choose between the two. You reach for Claude Fable 5 when you need that architectural judgment, that safety and planning taste. But you reach for GPT-5.6 Sol when you want rapid follow-through, parallel subagents, and just a relentless push to execute and finish the work right in front of it. So as you look at integrating these frontier models into your own pipelines, and you're routing those workloads between Sol, Terra, and Luna, you really have to ask yourself one foundational question about your specific use case. Do you need the model that sounds the smartest, or the one that finishes the work?